Just going to get started. Okay, welcome back everyone. I hope you're all sufficiently caffeinated and eating as many pastries as you possibly can. So my name is Laura Foster. Hello, I am the Associate Director for Tech and Innovation at techUK. I'm also the person who's probably responsible for sending you all the emails about this event, so I am sorry for that. I will also be your chair for the rest of the sessions today, and specifically the moderator for the next panel that we are going to have today, which is on quantum. So this is the first of our deep dive panel sessions on the different technology verticals that we're going to be exploring throughout the rest of the morning and the afternoon. So we'll be having sessions obviously on quantum right here, but also on things such as AI, robotics, semiconductors, and more. But starting off with the quantum panel, let's start with the good news. The UK is a world leader in quantum. We have more startups in the quantum space than anywhere else in Europe, and we are ranked second globally for commercialisation. And quantum policy is very unique here in the UK, that it is all underpinned by the National Quantum Strategy, which has already been mentioned today, and the associated 2.5 billion of funding for the next 10 years. All great. I'm sure we can all just get up and leave and not have a panel on quantum because of that, but not quite. As we move to commercialisation of quantum technologies, and as Seaman said on the previous panel, the UK really struggles to commercialise. So there is a lot that we need to overcome in the quantum space on that route towards commercialisation, whether that is how we can fund scale-ups or how we can build that very complex supply chain that's needed for large-scale commercialisation. There are a lot of challenges we still need to address. And so that is what we're going to be discussing on today's panel. And that is why I'm very glad that I'll be asking the questions on today's panel. And I'm joined by a panel of experts who are going to help with the answers to some of those big challenges. So getting us started, I'm going to ask each of the panelists to kindly introduce themselves along with the first question. And the first question I want to ask is, well, we held a panel on quantum technologies at the last Tech and Innovation Summit in November. We thought it'd be a good place to start the panel by asking each of you to share what your highlight has been since last November within working within the quantum space. I'm particularly going to go to Tom first, because Tom has kindly been nominated by the rest of the panel to also take the difficult question of explaining what quantum is.
Thanks, everyone. Fantastic. Am I on? Yeah, okay. Hi, I'm Tom Newby. I'm the head of the UK's Office for Quantum Technologies in the Department for Science, Innovation and Technology. So I'm sure some of you are aware that quantum technologies are those that are based on the physics of very small particles. And as a result of using those physics can do things that other technologies can't. That's, for example, using the quality of quantum entanglement, so particles being connected at a distance, or quantum superposition, so being able to occupy two kinds of states at the same time before they're measured. And what that allows us to do in future is to have computers that would simulate really complex systems, all sorts of applications, but the kind of lesser known applications are probably on sensing, really precise and better sensors, and on networking, potentially much more secure networking and communications. The applications of these technologies are really broad. I think that's the thing that's most exciting for me as the head of the UK office, is that we are at the foothills of working out what this will do to the economy, but we know it's going to be really broad, from financial services to transport to healthcare. And I'd say that's what's characterised my year. So I started as the head of the office last September. We just published the new national strategy. And my role is to sort of oversee and steward this national strategy and make it an all-government strategy. And what that means is I get to go out and about and meet lots of quantum companies, meet lots of quantum researchers, and actually genuinely see what is a world-leading ecosystem. I also get to travel and see and meet counterparts in foreign governments, and they say to me, the UK system is genuinely world-leading in all sorts of respects. And I can't claim any credit for it personally, but I'm very happy to take the compliments from them. And what we've been doing over the last year as the office has been really working with the ecosystem on what next. So we've got this really successful national programme, but we have been running it for 10 years. And the challenge is, how do we go from 10 years of excellent science and research and early commercialisation to the challenge I think that's been set for this panel, which is getting this technology into the economy to have real impact. So that's been my focus this year.
Thank you for getting us started.
Great. Well, I'm Womel, one of the co-founders of a spin-out from the University of Oxford called Quantum Dice. I and my co-founders were actually one of the teams that took research that was done as part of a PhD and commercialized it thanks to the generous support of a lot of the commercialization ecosystem here in the UK, especially for quantum technologies. So for example, after we formed the company, we were immediately able to take part in the Quantum Technology Enterprise Centre, which was part of the EPSRC funded program to help academic founders commercialize and raise VC funding to create a company around quantum technologies. And in essence, what we do is we focus on building a component that uses quantum technologies to generate random numbers for use in cybersecurity and also in simulations. And I think for me, the highlight of the past year is really seeing the conversations that I have with potential clients really change from being questioning about, what is quantum technologies, and also assuming that we are a quantum computing company, which we're not, to actually evolving to being more nuanced questions, because a lot of the customer conversations that we have had in the past year has actually been more in depth and being more focused, and our clients have actually come to us with requests for how they would like our particular key R&D product to be. So for me, this really shows that the commercialization market for quantum technologies has matured since we started the company back in 2019, and it's a really promising sign to the growth of this industry.
Fantastic. And I'd love to maybe tease out what you think's changed those conversations that you've been having with your customers, and we can get into that in a little bit more detail, but to Robert first.
Good morning. My name is Robert Lamb. I'm the Chief Research and Technology Officer for Electronics Division in Leonardo. So I'm based up at Edinburgh, but we have several major sites all over the UK. I'm also the Vice President for Business at the Institute of Physics. So in addressing the question of what's new for me and for Leonardo, I think over the last 12 months or so, in the area of quantum technology, I think it would be quantum information processing. As predominantly a sensor manufacturer, by which I mean we manufacture radars and advanced targeting systems, thermal imagers and the like, we've had quite a strong interest in quantum technology for well over a decade, principally focusing on low light level detection, guided mode detection, and in the form of LiDARs for active sensing, and also more recently free space optical communications. Those are fairly close to our core business interests. However, some time ago, say 18 months ago, I started to think about the use of quantum computing, because the technology for that was coming along, and perhaps more precisely quantum information processing. So it struck me that it was quite important from a strategic viewpoint to understand how quantum information processing could be applied to a generic problem concerned with the management and control of a distributed sensor network. That distribution of sensors being on many types of platform, be it satellites, aircraft, ships, etc. And how the sensors that collect data on those platforms can be best managed, both in terms of the data processing, the communication and interlinks between those platforms, and the ability of the commander, as it were, to make sense of the disposition, shall we say, and make informed judgments according to what that distributed sensor network is telling him. And to some extent, how it can self-organize and provide the commander with the right information rather than the sensor data that is required to make an informed decision. And the crux of that matter is optimization, for which quantum information processing is deemed to be the fruitful area of endeavor. So that's what I've started to engage in, and both with a specialist company and with academia, we started to engage in developing algorithms running on quantum computers, looking at quantum information processing.
Thank you. And Piers, to wrap this up.
Morning all, I'm Piers Clinton-Tafton. I'm a partner at EY, background 25 years in technology risk and cybersecurity, but the last 4 or 5 years been focusing on what we do around quantum, both in terms of looking at our own business and professional services, but also how we help our clients. And I think it has been a really fascinating year in terms of technological progress, and you can see some of the great things that are happening, particularly with some of the UK companies, including the NQCC's physical building in the last couple of weeks. I think what's been really interesting for me this year is if I look at kind of other technologies that have come along, AI and cloud, trust and transparency have been really important to allow companies to get comfortable with the transformation. And not just the NIST standards coming out this year around post-quantum cryptography, but actually things like the Regulatory Horizons Council view on how quantum technology should be regulated, the Responsible Quantum Industry Forum is really important actually to give people confidence in how these technologies are adopted in a safe way. And I think thinking about that for the future is really important. One of the things I'm really proud of this year is the work we did with the University of Oxford looking at responsible quantum computing. I think, again, speaking to our clients, they're starting to understand the transformation, but they also, as they have had with previous technologies, have questions around what does it mean for security, what are some of the risks, what could some of the things we need to be think about to adopt this responsibly be. So that's been, I think, how the conversation started to shift over the last year, mainly for me.
Fantastic, thank you. A few of you brought out there some of the early applications that we're starting to see in the quantum space. And obviously there's a plurality of quantum technologies, which we've touched on, and they're at different TRL levels, so they're at the different journey on the commercialization route. But we are starting to see that commercial application. So I just want to give everyone on the panel the opportunity. Are there any particular use cases or applications that you particularly want to highlight? And Wenmei, I'll go to you first, because I really want to talk about how there are so many applications beyond compute and the fantastic work that you guys are doing.
Sure, happy to. So I think what we do is we focus on just one aspect of quantum technologies, which is using quantum mechanics to generate high-speed and also verifiably secure random numbers for use in both classical and also post-quantum security, and also for use in enhancing simulations like Monte Carlo simulations. And for me, again, reflecting on how commercialization of these technologies have evolved in the past year. So to give some context, when Quantum Dice first started, we were focused on building hardware and we saw ourselves as a hardware company. But over the past 12 months, and also actually in reaction to customer demands, we actually pivoted to now also offering a software-based quantum entropy as a service solution. And for me, I think seeing this iteration of our product, which started off just being a server rack that's definitely hardware-based sales, to something that's based on the cloud and can be more easily distributed to our clients' sites, really shows me that there's a step forwards in terms of our thinking and also our clients' thinking on how and also where they can use the quantum technologies. And I think QNGs, it's probably been one of the types of technologies that's been pushed into commercialization probably the earliest. I think for me, seeing that quantum random number generators, they are kind of applications outside of cybersecurity, and also even within cybersecurity, there are demands for different form factors and different ways of consuming it. Really shows that this is a good step forward for commercialization.
And apologies, I'm jumping around the questions already. That's really bad of me. But you mentioned earlier that a lot of you're noticing a change in how you're talking to your potential customers and clients. And you also mentioned there how that has kind of driven your business model over the last 12 months. I want to touch on market readiness just here. What do you think is driving that change in this understanding of quantum technologies?
That's a good question. From what I have seen and in our conversations, a huge part of it is actually standards development. So I think Piers earlier mentioned NIST is releasing new PQC selections this year, and as they have done last year. Because we fit into security, that actually feeds down to our particular product sector. And also interestingly, over the past few years, we have been working with the National Physical Laboratory here in the UK, where they really led this kind of consortium of companies and QNG vendors to develop new standards to see how we can actually assure and also measure quantum random number generators, especially for security applications. And I think now that project has concluded, I'm really looking forward to seeing how the NPL then feeds that outward. So perhaps engaging with NIST in the US to see how these standards can then be actually formalized into something that's commercial, and that will in turn, I guess, help to strengthen our buyers' internal propositions when they want to purchase and upgrade to new quantum technologies.
Fantastic, thank you. Tom, obviously we've got the National Quantum Technology Showcase happening on Friday, which is a really big event where lots of different quantum businesses from the UK, but also around the world, come and showcase their technologies, and you'll be very involved in that event. So you're very aware of the different use cases and applications. Is there any in particular that you would like to highlight?
I often say picking applications is a bit like, picking your favourite children. There's so many. One I would probably highlight because of its importance to the economy and to different kind of sectors is quantum position navigation and timing. So the improved ability to map gravity through quantum sensors and more precise atomic clocks could allow us to have more resilient navigation on things like ships, planes, trains, and that's particularly important in the case of GPS denial. And that's a really significant thing, because if GPS is denied, it could impact the UK economy by £1 billion a day. That might be because of a weather event, but it could also be because of bad actors. So I think there's real potential there. And what we've seen in the last sort of 6 months to a year is a number of commercial trials by different companies starting to look at what can be done. So I think that's very interesting.
And so it's quantum as this product that can be used, but it's also the critical use of quantum for things like resiliency, which the new government talks about a lot. Perfect. Okay, I want to move the conversation on ever so slightly and focus again on that commercialization point. And there's two main points that I do want to focus on here. And so the first one we've already talked about, which is market readiness, and we'll get more onto that in just a second. But then the second point is supply chain capability, and that's what I want to start with here. So as quantum moves on its journey towards commercialization, what type of infrastructure capability does the UK need to build that here? And this was touched on by Helen very briefly in the previous panel with her report from the Royal Academy of Engineering. So we can definitely build upon that. And Robert, I'd like to direct that conversation to you.
Okay, if we focus on infrastructure, what springs to mind for many quantum technologies that we would be interested in, it splits down in my mind to either a photonic versus semiconductor or an integration between the two. And so the national infrastructure that's required, I think, to commercialize either a next generation semiconductor or a next generation photonic component of a photonic integrated circuit can only be realized if that infrastructure is able to cater for small to medium volume manufacturing. We like to talk about high volume manufacturing and scale up. It's not simply that the defense industry is by and large, a small to medium manufacturing infrastructure or industry. It's that the components themselves support quite a broad area of technology, manufacturing capability, both within quantum and outside of quantum. I'll give a specific example, which is close to me, is photonic integrated circuits. And the bespoke nature of an optimized circuit to do a particular job means that the infrastructure that's required to manufacture medium scale, shall we say, is actually quite diverse. So it usually comes down to the need or acknowledgement for open access foundries, both either photonic or semiconductor. But the argument might go further to emphasize the need for more than one open access foundry to specialize, each one specializing in a particular application or manufacturing approach, because the optimized component will require a reconfiguration depending on the application area that is targeted for. And it's doubtful, at least in my mind, that one foundry would be able to cater for the diverse requirements that a quantum technology taken as a whole, or industry manufacturing taken as a whole, would be able to cater for. So I think it's an acknowledgement and understanding of how many and what type of open access foundry would be required for manufacturing. I think that's a key point.
Is that reasonable for the UK, though, to have multiple open access foundries?
It's not reasonable for the UK to try to address every single eventuality. Yeah. Supply chains are international, and so some understanding of where we would fit in the general trade space, international trade space, and globally, has to be acknowledged. And then we pick and choose our moment accordingly, fund it, and bring it to fruition. And there's a reference to that both in the two documents that were mentioned in a question earlier today regarding the semiconductor strategy document and the quantum infrastructure review documents that came out earlier this year. And there was a brief reference to the green paper on industry strategy as well. Yeah. And what struck me about that, without stealing too much from your question, is a brief comment to a 10-year plan. Yeah. That stuck in my mind because that 10-year plan must emphasize continuity, and I think it's very important to invest in what manufacturing capability infrastructure is required and maintain that support until it becomes commercially viable.
100%. And we can stray from the conversation slightly. And at techUK, we advocate for the fact that the National Quantum Strategy and the work that's happening through the National Quantum Technologies Programme should be continued through anything that comes out with the industrial strategy as well. I want to pause and see if Pierce or anyone else wants to comment on this question on supply chains.
And I'd agree with much of what Robert said. I think that piece, if you look at it, we're a large global company. Many of our clients are large global companies, and they do want confidence in the globally integrated supply chain. Again, how we, to your point, integrate and work with others and navigate things that are shaping slowly around export controls, etc., is really important, I think, for the future success of the UK and the industry as a whole.
Fantastic. And Tom, how is government helping build infrastructure?
I think the first thing to say is that we've got some fantastic infrastructure in the UK already to support the kind of R&D base for quantum, whether that's through the National Physical Laboratory, through the Hartree Centre, or through the National Quantum Computing Centre. But we commissioned that report from the Royal Academy of Engineering because we knew that the infrastructure we have now, as we've been discussing, won't be sufficient for scaling. And so what we're doing now in government is looking at that report, looking at the semiconductors report and prioritising infrastructure needs across our emerging technologies. And I think what's really interesting is where can we achieve a double or triple word score in some of these, so facilities that will enable competitiveness across different technologies. That's part of the conversation in the spending review that's ongoing at the moment, and that will be a really important focus for my team. The other thing that is really important in this space is how we help fund private companies to build infrastructure, right? Yeah. So it's not all about government R&D facilities. And we've just announced the National Wealth Fund at the Investment Summit. That will have a real focus on building kind of infrastructure to support and drive the needs of the government's industrial strategy. So I think still lots of detail to come on exactly where and what it will invest in. But these kind of big projects over time is certainly the kind of thing I'd hope it would be able to support.
Fantastic. And just to push on one thing, so it did come up in a previous panel, just very quickly from a policy perspective, how does, for example, the work on the National Semiconductor Strategy interact with the work on the National Quantum Strategy?
A lot, obviously, because there are chips in lots of these products, and we have to think about how we work together, and a lot of the fundamental enablers are similar, so the kind of importance of the UK's photonics sector to both sectors, and we need that kind of thriving base for both. So we talk to what we have historically called critical technology teams, emerging technology teams in government all the time. One of the opportunities of having a Department for Science is that we're all together, and we're going through a process in this spending review, thinking about future interventions, is where might we achieve shared goals and outcomes through some of these interventions. Skills is a really obvious one, where, yes, there are some very specialist needs from the quantum sector, but there are also a lot of shared needs around technical skills, around engineering, where we don't want our technologies they will be competing, but we want to be growing the base so that they can all flourish. So there's quite a lot of joint working between the teams leading those strategies on where we can do those things, and we're very conscious that the signals we send to one sector will also impact on the other, so that's playing into how we think about the industrial strategy as well.
Fantastic. Okay, I want to try and link a few themes here together now, so bear with me. So we've talked a little bit about the supply chain that's needed for commercialization to happen, and I'm going to move us a little bit onto market readiness. But one bit that is a little bit of an intersection there is how we better support our quantum scale-ups, of which the UK has a fantastic base, including Quantum Dice, which is sitting on the panel. So I thought it's a good opportunity to ask you, what else can we be doing to better support our amazing quantum startups and scale-ups?
I think for us and maybe for other quantum startups, I think clarity around potential export regulations.
Okay.
And also easy access for maybe quite small teams to without much of I guess export experience to access maybe government expertise, especially when it comes to exporting developing products into other markets.
Fantastic. Okay, before I move us on, does anyone want to come back on any of the points that have already been mentioned?
I just make a point that fundamental to scale-up is demand. And in many of these, we talk about the quantum technology industry. I think it's probably more than one industry because there's more than one technology involved with more than one application. So that complicates matters. But in order to fuel scale-up, there has to be a commercial demand, because without that, it'll fizzle out. That's a difficult question to answer, is how to encourage customer demand. But that's, I think, is a key element.
Let's maybe focus on that customer demand then. And Tom, I'm going to come back to you. What do you, and this is touched on in the National Quantum Strategy actually, what is the role of government maybe being that first customer and to help maybe set that level of clarity and certainty about how these technologies can be used?
I think it's really important, and we said a lot about that, as you say, in the strategy, because some of these technologies have really long development pathways. They're highly risky. I'd say quantum is at the kind of riskier end of the deep tech spectrum, and we know that means the signals that government sends are going to be really crucial to providing some of that de-risking and making sure that we have a market that we can serve in the UK. So that's part of what we're doing through the testbeds program. We're, as a customer, buying access to different quantum computing modalities so that we can better understand it, ensure that others in government and the public sector can, and then also wider users can as well. And over time, as I think some of these technologies go up the TRL levels, it's going to be really important that the big public sector users are around the table. And that's one of the focuses of my team in the last year, has been to try and extend understanding inside government of the potential of these technologies. I'd say really good understanding in the Ministry of Defence, in our intelligence services, have been thinking about these things for a long time. And I think increasing understanding and engagement from the Department for Health, from the Department for Transport and Net Zero, which is actually really exciting. So I think it's going to be key. It will take time, because not all of these technologies are ready, and naturally departments need to be careful with taxpayers' money and the signals they send. I think already we're starting to be able to show that through our work on the quantum missions and those focuses, and then through the testbeds program as well.
Yeah, we did an event with the Department for Transport, and they came along and talked about how quantum optimization actually is one of the main use cases for the transport sector. I think that segues us very nicely actually onto this conversation around market readiness. And obviously government as a first customer is one way that you can signify market readiness, but Pierce, I'd love to come to you on this. So how are you potentially working with people, and how do we help these end users understand why quantum can be useful for them?
Absolutely, and I think in my experience speaking to end users, it is a bit of a three-step process. The first point is demystifying, because a lot of people will still come and say, I've heard about quantum computing, and within quantum computing I've heard it can break cryptography. So part of it is stepping back and say, okay, well, let's reorientate to a conversation around quantum technologies and some of the use cases for those overall. I think the second piece is demonstrating, in terms of actually saying, okay, well, when we look at those use cases for your industries, what are they? In professional services, we're very interested in data-led things, including QRNG and what they can do. Equally, some of our clients in industrials are much more focused on the sensing, to your point. So having a good view as to what we can do there is really important. And that was part of the drive of the work we did with the NQCC a few years ago, to look at some of the quantum readiness by industry. And I think the third thing is then developing in terms of, okay, if you've understood the overall landscape of technologies, you understand some of the use cases, what is a sensible next step? And a sensible next step in many cases is to go off and to do a proof of concept, to look at how it can be applied. And we're seeing lots of people doing lots of interesting proof of concepts, whether it's around optimization, whether it's around looking at QRNG in Monte Carlo simulation, whether it's looking at how aspects of certain quantum computing modalities can support machine learning. And the feedback we get from all of those is it's useful in terms of thinking about that next step towards commercialization.
Fantastic. I'm going to come back to you on points around quantum resiliency, because I'm very aware that we've spent this entire panel talking about the opportunities of quantum, when actually, when a lot of people are faced with quantum, they actually go, is this going to break all of the data that I have? So let's come back to that in a second. But Robert, this is exactly what you were talking about, right, when you were identifying the different use cases that you were exploring. Do you maybe want to come back to that and talk about how you're working on developing market readiness?
Well, market readiness. Okay, that was a little bit, but the question seemed good until you got to the end. It's a partnership. The defence industry is a partnership between government, Ministry of Defence, the end user of the technology, and who define the requirements, and the manufacturing infrastructure, such as ourselves and others. So that partnership leads to a sort of market opportunity over quite a long time scale, because the new technologies, when you're trying to address a particular end user application and introduce a new technology to demonstrate its ability to do something which the incumbent technology is not able to do, there's a little bit of nebulous conceptualization of what is required, because that new technology, first of all, is immature. So when you build it into some sort of test demonstration, you're pretty sure it's not going to work satisfactorily, but what you're learning is two things: how the technology works in terms of an end user application, and also its manufacturability. Military equipment tends to be fairly complex, and it is interdependent on other technologies for the actual end user functionality to be shown and demonstrated to be beneficial. These are very long interactions between customers and our own development processes to bring a technology to a market. Coupled with that is the supply chain development, because what perhaps isn't fully appreciated is that defense equipment in particular, or large organizations such as like Leonardo, our products are quite complex integrated systems which are reliant on a broad range of technologies which are actually in the component. And so we rely on the establishment of a new generation of supply chain that takes that emerging technology from academia, puts it into a component that we can either specify or request, shall we say, and put that into test pieces of equipment, test infrastructure, take it out on a field trial and test how it works, come back with some sort of assessment, and then that's fed back in terms of what is required, how that technology can be manipulated and improved upon, and then that message translated down throughout the supply chain to find out what is actually practical. So that's quite a long story or response to your question, but in the defense area, it's rather a complicated situation. It's not a simple bring technology to market in isolation. It's an integration of several components, some being new, some well established, and it's getting that marriage between the new and the old, the well established and reliable and familiar with those which are less reliable or less understood, and getting that to some form of manufacturing perfection.
Fantastic, thank you. Not necessarily in the defence space, but while Robert was talking there, I was thinking about the quantum missions and how a lot of the challenges that Robert was highlighting is kind of the goals of the quantum missions to try and solve, right? So I don't know if it's worthwhile for the audience maybe giving a quick overview as to what the quantum missions are and how they fit into the National Quantum Strategy.
Yeah, so we published the quantum missions last year, and this followed the quantum strategy. And the idea behind these was to set some quite specific concrete outcomes that the UK ecosystem should work towards, to be a focus for government investment and all the levers we have, but also to be a focus for private investment. Because what was clear is in the next 10 years, just focusing on broad capability was not going to be enough and to cut it. So we have a mission on quantum computing and quite an ambitious mission on being able to get usable quantum computers impact across sectors by 2035. That's really quite punchy, but also we think the competitiveness of the UK ecosystem means we can get there. We have a mission on quantum networking, about having a really advanced world-leading quantum network on a similar timeline. And we have 3 different sensing missions. So one focused on position, navigation and timing, so the kind of applications I referenced earlier around navigation on airlines in terms of aircraft, in terms of resilience there. Or sensing for critical national infrastructure, potentially kind of distributed sensors, and sensing for healthcare as well. And I think what has been really useful about these missions is they basically helped us build on existing communities of practice, so research communities, industry, and then bringing some users in, including government users, to how we develop the pathways of the technology. So helping us get a sense of where might we go in the next few years, what kind of government action is needed, but also how can industry prepare. And I guess that's key for us, because we want to make sure there is a market there for this stuff.
Perfect. Pierce, to you, quantum resiliency. How do we navigate this conversation around quantum security? And we've already touched on, for example, the NIST standards and how that is helping drive the conversation. I think the message is don't panic, but prepare. What conversations are you having?
I mean, I think that is exactly the message. So kind of at a summary level, as many people probably know, there's an expectation when we have fully fault-tolerant quantum computers, they will be able to break much of the cryptography that we use to secure communications today. There's also a belief that in the interim, there are likely to be people who are capturing and recording our current communications with a view to later decrypting them through what's known as a harvest now, decrypt later attack. And that's been known for a reasonable amount of time. As I said earlier, this year, NIST has released the first set of standards around post-quantum cryptography and how we protect against that. And it was great to see that the NCSC, in response to that, said they would be putting out guidance for the UK in 2025. In terms of the response that we're seeing in the market, it is not panic, it is thinking about it in the context of a risk. This is a risk which is potentially lower probability the closer to today you look, but could be significantly high impact. And therefore, as a business, what does it mean to us into the sorts of data that we currently hold, the lifetime of that data? What does it mean to us if we are manufacturing devices that might be out there for a long time? And what are the steps that we want to take to in the interim, which might be around understanding our cryptographic inventory, our data flows, how our own supply chain is getting ready. And that's where many of the organisations are. Clearly, there are some of our other clients further along in areas like financial services, where they expect regulation around this to come sooner. But our kind of encouragement to clients is to think through the risk, and to think through the risk in the context of other risks you might have. If you are an organisation that has no passwords, no user access provisioning, and doesn't patch something, putting all of your efforts into post-quantum cryptography might not be the most principal first thing to do. So again, thinking about it as a risk, and as a risk, continually monitoring progress of this. And again, I think the guidance from the NCSC is something we're all looking forward to next year.
You were nodding, Tom. Do you want to come in on anything there?
Yeah, so our National Cybersecurity Centre plans to put out more guidance next year on how industry should be thinking about preparing for post-quantum cryptography. I mean, I think just to build on what you were saying is that they would say in the first instance, good cyber hygiene is essential, and obviously all businesses should be investing in that, because that's a key line of defence against that harvest now, decrypt later, but also just conventional cyber attacks. But also it's important to be thinking about this transition too, so there'll be more guidance coming there.
And the great thing is, I know again it's slightly to the side, there are aspects of future quantum technologies, including QKD and QRNG, which over time may also contribute to some of the solution as well as the problem. So it's not all downside on security.
Yeah, and on QKD, it's also very important for quantum compute, which is probably not a conversation we're going to get into today. But I'm going to pause and see if there's any audience questions. But just a shameless plug before I do that, techUK does have a paper that we published over the summer for our members, just try and get that basic understanding and to grips with what the idea of quantum resiliency is. And Piers helped us on that paper. So I'm happy to share any links afterwards. We've got 2 questions here in the front, so we'll go to you first and then here. We've just got a mic coming.
Andy Sellers from Silicon Catalyst. So Robert referred to the need for an open access compound semiconductor foundry and also a facility that can do photonic integrated circuits, and about sort of fostering the SME community and getting access to them. So I was going to reflect on the fact that 2 months ago, the government nationalised the Newton Aycliffe site that is now Optric. It's, to the best of my knowledge, it produces compound semiconductor devices. We have Cornerstone at Southampton University, which is also producing photonic integrated circuits. So those are 2 of the building blocks, I guess, that Robert referred to. Silicon Catalyst has worked with 24 companies, returning a 20x investment on those companies. One of the things they need to do is to produce early stage demonstrators in order to attract investment. So I guess my question is, how do we facilitate access to those 2 pieces of infrastructure I've mentioned, and what else is needed in order to kind of make that ecosystem work?
Well, let me think now. I'm not that familiar with Cornerstone, but I hope to grow my interaction with Cornerstone in the near future for various reasons. So I have to take a slightly guarded view, because my understanding is, if I just think about a photonic foundry rather than a semiconductor foundry. A meeting that I attended very recently, an international meeting at which Cornerstone was represented, did draw attention to what I mentioned earlier on, that the number of applications for photonics is very, very vast, and photonic integrated circuits in particular is quite broad. And therefore, the manufacturing infrastructure in the UK to address those requires some careful thought as to what a commercially run, by which I mean a commercially run foundry aimed at operating in a manner which will satisfy the immediate customer's requirement, rather than one which is partially looking at external customers but also supporting academic research. There's always a bit of a conflict there in the management dichotomy there. So what came out of that debate was the recognition that the fine design of many photonic integrated circuits to address particular applications was quite broad, and therefore, as a result of that, one particular open access foundry might not suffice. One might draw a parallel with that and say the same thing for a semiconductor foundry, I should say. But again, it comes down to specifics as to what type of semiconductor we're talking about, as opposed to what type of photonic foundry, not just silicon, but thin film, lithium niobate, for example, silicon nitride, etc., and other materials which are coming on the scene or deemed to be coming on the scene in the near future. So I can't really answer the question any more specifically than that, only to acknowledge that a number of open access foundries needs to be considered, and that comes back to a point yourself made about where does the UK fit in an international trade or international supply chain that I alluded to earlier on.
Fantastic, thank you. And then we had a question just behind.
Thanks. Jazz Rasool. I'm on the Skills and Diversity Council for techUK. And back in the 90s, I was doing my master's degree in looking at computer modelling of drugs that work on the brain, specifically using Monte Carlo methods and quantum physics methods to do that. But while I was doing that, I was studying epilepsy drugs and anaesthetics and looking also at the brain and how it functions. And I'm conscious that with the rising use of AI these days, a lot of technologies, they're very von Neumann in their architecture, and they have a processor in the center, and they have data around the outside. From an astronomer background that I have, that reminds me very much of the old model of the solar system, where we had Earth at the center, and we have everything else orbiting it, and it turned out to be completely wrong, and everything needed to be swapped around in order for the fudges and fixes no longer to be necessary. And I'm just wondering, I'd like to ask each of the panel, do you think the future of computing, especially quantum computing, is going to be one where processors are still at the center of computer architectures, or are we going to see something completely different?
I'm happy to give a first answer to that. We were talking about neuromorphic computing, interestingly, just before the panel started. I think on the brain and the brain piece, the first thing I want to say is there's some fascinating work being done out of Nottingham in the UK, actually around using quantum sensing for epilepsy. And so people who are interested in that, I would encourage you to go and look at that in terms of some of the MEG stuff that they have built. In terms of the computer architecture, I don't think that you can look at quantum computing in isolation. It is going to converge with cloud, with AI, and we're starting to see that in terms of some of the experiments that we're doing, for example, looking at kind of boson sampling and some of the kind of machine learning there. I think the future, it is likely to, in the longer term, collide with kind of neuromorphic and photonic and other computing architectures that are coming. I'm not sure we, or at least I, have a firm view of how that's colliding. That's certainly an area that we're keeping an eye on in the medium to long term in terms of how some of these things converge. And I think just briefly, that's why it's also important, going back to the very start, around things like regulation. I think if we try and regulate this stuff in a box around, if it's AI, open it up and do this, if it's quantum, do this, if it's cloud, do this, we're probably going to set ourselves up, to your point around thinking about kind of some of the other aspects of this, for challenges in the future. So I think it will converge with many of the other technology things we're seeing today, and some of the things you mentioned in the future, including neuromorphic and photonic as they evolve. Robert?
Well, I'd agree with that view and say that I wouldn't say regardless, that's probably too strong a word to use, but as quantum computing increases in the computational power, I don't see classical computing disappearing into the sunset. I think it'll be a hybrid. What I guess in a roundabout way is where a classical computer is cost effective, not necessarily the fastest, but possibly the fastest, then it'll be reserved for those types of problems will be reserved for classical. And a similar story for quantum. I think it's a question of whichever is the best computational scheme to address the problem at hand will be the one that's used, subject to its commercial viability.
Yeah, it's about the right tool for the problem, really. We have time probably for one more really quick question, which I think was just here.
A quick question, mainly for Tom and then anyone else who wants to join in. Quantum computing has traditionally been focused on looking at quantum supremacy, looking at problems where quantum can be much more effective than classical compute in terms of the sheer computing capability of the problem. However, in parallel, you've seen the rise of AI and you've seen the amount of energy that LLMs are consuming and some of the forecasts people have in terms of what it can do to the planet if we have to go down that route. Sorry, by the way, I'm Nanda from Hewlett-Packard Enterprise. What's really interested me about quantum and what I've been pushing for some time is the fact that quantum actually uses infinitesimally amounts of energy compared to classical compute when it comes to these sort of problems. And is it time to pivot away from the focus on quantum computing being quantum supremacy from a compute aspect to what it can do from an energy viewpoint? And is that a differentiation that the UK can make? Because I don't, I think classically, not for any bad reasons, quantum has been dominated by academics, and academics love complexity. Whereas the real problem that I think quantum can solve is actually energy efficiency.
So I agree that we can't just focus on quantum supremacy in its kind of conventional sense. That's sort of almost like one metric, and actually a very contested one at that. And we have to think about different objectives in government. That's absolutely got to be at the centre of the thinking, and we think about it for a few different ways. So I suppose efficiency absolutely is one thing. I suppose the other side of it is where can quantum computers be applied to actually address big questions of kind of net zero, about whether that's developing new battery materials or chemicals, problems like nitrogen fixing as well. So I think we see real opportunity in the net zero space. And I think it is, I'd be interested in having a conversation with you offline actually a little bit more about your perspective and Hewlett Packard's on the efficiency question, because I've heard actually different things from the sector on how confident they are that will come or not. So it'd be interesting to hear others from the panel how confident they are. The other thing I think we need to think really carefully about is the sort of environmental impacts in the supply chains, obviously, because we rely on quite a lot of critical materials and minerals for these computers. So it's something that, as we do some of our work on the supply chain route, it's not just about the energy use, but also all the other things that go into the machines. It's going to be really important.
Fantastic. So I've managed to successfully take an agenda that was running to time over time. So what I'm going to very quickly do is ask all of the speakers in a sentence, what is the final message you would like to leave the audience with today? And Tom, because you sat next to me, you're going to go first.
Well, I mean, I think you've probably heard a lot about AI today, and it's a real focus and something I think maybe some companies and some governments might say, oh, we were caught by surprise by in the last 2 or 3 years with LLMs. I think with quantum, there's a real opportunity for those that get there first to really shape, as governments, but also as companies, where this technology goes. And I encourage you to embrace it and come talk to us in government about how we can help.
Thank you.
For me, it's to keep exploring quantum, and maybe just to follow up on the last question about energy efficiency. When we kind of did the proof of concept with HSBC and also with the Hartree Centre and using QRNGs for Monte Carlo simulations, we actually found that using higher quality randomness reduced the number of steps needed to reach convergence for certain Monte Carlo simulations. And for the users, this could have a huge, cost and also energy saving benefit. But yeah, happy to talk about that in more detail offline.
Well, by way of a message or a point, again, to pick up on your question, since you mentioned energy efficiency, I see it not as a reference directly anyway to quantum computing, but a dichotomy between the microchip industry and electron-based computing and photonic-based data processing. Because to address the ever-increasing power requirements to process ever-increasing volumes of data, that critical issue of the electricity bill is required, by which I mean the cost of ownership to run the calculating machines needed to process the data, has to be addressed. And I see a photonic-based data processing architecture as being a key to that. And again, I use that word hybrid, this time not classical versus quantum, but hybrid microelectronic versus or integrated with photonic-based processing. And I think that is what will be of major interest over the next decade.
Fantastic. I mean, I would echo that quantum technologies do have the possibility of transforming industries, but also, as we've just touched on, perhaps solving some of the large challenges we face as societies. So my encouragement would also be to have a look, get involved, dip your toe, and it's more fun to go together. So we've got some great startups and resources in the UK, so please make use of them.
Fantastic. And let's thank the panellists in the usual way.